Right, for this exercise, the first thing that we want to do is come up with the overhead rate using the traditional approach. Right, so again, we're simply going to take our direct labor cost and divide that into our estimated overhead, which was given. Again, we know that our direct labor costs are $180,000, and we also know that our estimated overhead costs are $342,000. Right, our overhead rate using the traditional approach is 190% of direct labor cost. Right, in part B, we're going to calculate overhead rates using the activity-based costing approach. Again, we know the estimated overhead for the machining cost pool is $22,000, and we know that the machine setup is $120,000. We also know the expected use of cost drivers. Again, it's $3,000 for the machine hours and $600 for setup hours. If we divide our cost drivers into our estimated overhead, we get an ABC activity rate of $74. For the machining cost pool, again, that's simply by taking B divided by A. And if we do a similar exercise for the machine setup, we get an activity rate of $200. All right, let's focus on the traditional costing. Right, so we know that our standard handbag required $60,000 of direct labor cost, and we know that our predetermined overhead rate was 190%, which means we're going to allocate $114,000 to our standard handbag. We're going to do a very similar exercise, except that our direct labor cost for the custom handbag is $120,000. We're going to multiply that by 190%, so we're going to allocate $228,000 to the custom handbag. All right, let's take a look at activity-based costing. And again, in this example, we have two cost pools. We have our machine cost pool, and we have our machine setup. And you can see that we're taking our expected use and multiplying that by our overhead rate, and $74 for our machining cost pool, and that overhead rate for the machine setup is $200. Again, if we add up the cost, you can see that we're going to allocate $131,000 of overhead to the standard handbag, whereas the custom handbag will be allocated $211,000. All right, we're going to do a similar exercise for 17.3. Let's start by looking at the traditional approach. Again, we know that our estimated manufacturing overhead is $1,040,000. We also know that our direct labor hours are 520,000, which means our predetermined overhead rate is $2 per direct labor hour. All right, if we're going to allocate this to the wool, we're simply going to take the direct labor hours, which is 260,000, and multiply that by $2. And we're going to do the same thing for cotton, which means of that $1,040,000, we're going to equally allocate that to both wool and cotton. All right, let's take a look at if we were to implement ABC. All right, let's first come up with our cost drivers. We know that we need 200,000 machine hours. We also know that we have $1,500 or 1,500 setups. So we're going to come up with that activity-based overhead rate by simply dividing the cost driver into our total manufacturing cost. And again, the overhead rate for our cutting cost pool is $2.50, and the overhead rate for our design cost pool is $360. All right, so now we have to allocate that to the products. Again, if wool is going to require 1,000 hours, we're simply going to multiply that by 250. And we're going to do a similar thing for cotton. And then when it comes to design, we know that wool requires 1,000 designs at 360, whereas cotton is only going to require 500 designs at 360. And you can see that the amount of overhead that we allocate to wool is 610,000, and the amount of overhead we allocate to cotton is 430,000. All right, let's take a look at our last exercise. And again, the first thing we want to do is determine the overhead that we would assign to car wheels and car trucks, assuming direct labor hours are used. So we're going to use the traditional method. All right, so we're going to take our estimated overhead cost. Again, it's $952,200. That's given to us. And we're simply going to divide by our total direct labor hours. In this case, it's 180,000 to arrive at our predetermined overhead rate of $5.29 per direct labor hour. All All right, let's just allocate that to the products. Again, the car wheels are expected 60,000 direct labor hours. If we multiply that by the predetermined overhead rate, we're going to allocate $317,400 to the car wheels. Again, the truck is going to require 120,000 direct labor hours. We're going to multiply that by the predetermined overhead rate of $5.29, in which case we're going to allocate $634,800 to the truck wheels. All right, the next thing we need to do is we're going to assign it to our product lines. Again, we're simply going to take that expected use for the car wheels and multiply that by the overhead rate. And when we do that, if we add up the overhead costs that are allocated, you get $400,880. All right, we're going to do a very similar thing for our truck wheels. And again, if we take our expected use and multiply that by the overhead rates, we will come up with $551,321 is allocated to the truck wheels. Assuming that the cost drivers are a reasonable representation of what is occurring in the two product lines, it would seem appropriate to switch to ABC. By using this system, more accurate cost information is developed, which should lead to better allocation of resources and pricing decisions in the future.